Hi, Hamid.
Hi, hello.
Fine.
Good.
Hello.
Just a moment, let me open the document.
Okay.
Okay.
Please hold on. Okay. Today we will look into an important topic. The thing is, apart from the technologies which are prescribed in our course, uh, like core Java, advanced Java, JDBC, Solid, JSP, Struts, Spring, Hibernate. So apart from this, you need many things to go through. Uh, Among them, the coding standards, one of the important things we have seen. So likewise, design patterns is a topic. So where you may get questions in interview from this design pattern, there is a chance. And these design patterns are
O-
used in application development also. Okay.
Okay.
The model view controller architecture, which we have seen with Sullets and JSPs, if you remember, those controller class, bean class, model layer or service layer, then DAO pattern.
Yes.
So over there, the MVC model view controller architecture is a design pattern actually. So a design pattern is a kind of solution that is applied for a recurring problem in your application. The thing is,
Okay.
we write applications, develop applications, and we maintain them. So
Yes.
maintenance is a crucial part on an application once it is developed. So while
Okay.
maintenance, the code, whatever is to be analyzed, should be clean. That is why the coding standards, if you adopt while developing the application, then things become easy while maintaining the application. So over
Okay.
there, the design patterns like MVC, which is very, very, very popular. So we have many more design patterns, and you should be aware of some design patterns. I'll highlight them in our session today. Rest of them,
Okay.
which we go through, are for our knowledge purpose. Whatever
Okay.
the important things, I'll highlight, and you have to understand what it is, and we should be able to write a simple program using that. Okay,
Okay.
fine. So here, can you see my screen now?
No, it's still on the
Yes,
Eclipse. Yeah, I can see.
right. Design patterns. Can you see a title?
Yes.
Fine. Yes. Design pattern is a general reusable solution to a commonly occurring problem in a software design. So while designing your software itself, these design patterns are recommended. A design pattern is not a finished design that can be transformed directly into the code. So it
Mm-hmm.
is a description or a template for how to solve a problem. That is what in our MVC design pattern, how to solve a problem in the sense we
Yes.
had problems with our MVC design. I mean, before the application embedding with MVC design pattern, there were requirements like if you remember
Yes.
the UI part, user interface part should be
Yeah.
independently developed from the business logic, right?
Mm-hmm.
And the business
Right.
logic also should not depend upon the UI part. One reason, so that maintenance becomes easy. The UI part is assigned to graphic designers, and the business logic part can be assigned to programmers, Java programmers, right?
Right.
Second, today you may be using MySQL database, and
Yes.
tomorrow you may be moving to Oracle database or some other XYZ database. In that case, your application should not be made much changes. With a simple configuration, your application should be able to migrate to new database, right?
Yes.
So
Right.
these two problems were addressed with the MVC design pattern, if you remember, right?
Right.
So a design pattern is a description or a template. So that's what over there I told you. UI part I have segregated. Then business logic part I have put in model beans and model layer. Then the data accessing part I have pushed to DAO layer. Do you remember? If you remember all those things I have done with my MVC application, right?
Right.
So here, this is a description or a template for how to solve a problem that can be used in many different situations. So maybe in your application there may be n number of situations, but still you are, I mean, you are used to do with the MVC design pattern itself. So like MVC, there are many more patterns. So design patterns evolve to ensure
Okay.
one or more of the design principles that are applied. So while designing the applications, there may be some principles. So to achieve that, these design patterns are used in application development.
Okay.
Um, so there are various design patterns. So J2E patterns, dotted patterns, GOF stands for Gang of Four. So there were four people who designed these patterns. So on their name, these
Okay.
GOF patterns was uh, named. These
Oh.
you can see the dotted and J2E design patterns evolved from the GOF. You can see, if you
Mm.
see the diagram here, GOF is on the bottom. On top of that, J2E patterns and dotted patterns are there,
Yes.
right? So in
Right.
addition to the GOF patterns, dotted and J2E has defined more patterns. So
Mm-hmm.
J2E has more number of patterns. So here GOF refers to gang of four. So these four are the names of those people who were the author of the design patterns textbook. So Erich Gamma, Richard Hem, and Ralph Johnson and Johnson. Besides, these are the
What?
four people who proposed and written a textbook called design patterns. Okay,
Okay.
that is why we call them as young of four patterns. So
Mm.
the types of in GOF patterns, gang of four patterns, creational pattern, structural pattern, behavioral pattern.
Yeah.
So there may be a chance in your interview, they may broadly ask you what are the types of design patterns. So you can
Mm.
come across this creational, structural, behavioral. Okay,
Yes.
I believe these patterns you might have seen in your academics. I strongly believe you might have seen it.
Mm.
Do you?
Patterns? No.
In your academics, maybe in your MSR graduation.
Me, I did. We did it.
Right,
Me, I
right, right.
didn't. Mm.
You did or you did?
I said I did.
Wow, okay. The other one?
I didn't.
Okay, for you it was not there. So this is an optional subject. I have seen here in my MS. I have seen. So I mean, design patterns is a separate subject. There were optional subject, and maybe some universities would be. I mean, the faculty over there might have chosen some other subject in place of this design patterns in your academics. Maybe. For the other one, I am telling you, because this is one of the important things, and we have to have in our university curriculum. Yes, I'm just browsing through these things. Okay, so
Okay.
design pattern, creational pattern. So these are patterns related to various mechanisms for creating the objects based upon different situations.
Mm-hmm.
So the name itself says. So this talks about creating the objects. So in how many ways we create the objects.
Mm-hmm.
And structural patterns. So structural patterns are those design patterns used to define structures of objects and classes that can work together and realize complex functionality present in the object. So here, Java is an object-oriented programming language. So whatever the functionality you need to achieve you are going to write a class, and inside that class you are going to put some variables and methods, and you are going to write that logic inside the method.
Yes.
And finally you are going to create an object, right?
Right.
Creating an object, then what that object should contain? Structure, the variables and methods. So this talks about structural pattern.
Yes.
Patterns to make system highly cohesive and loosely coupled. So what do you mean by cohesion and coupling?
Fine. Awesome.
Have you heard of these two terminology? Cohesion and coupling.
I've heard of loosely coupled in embedded systems.
Okay.
Yes, but I don't remember the definition.
This is one of the important questions in interview. There may be a chance. So, I mean, to see this question. There is a rule in software design that your application should be highly cohesive and loosely coupled. So this is a kind of formula kind. This one, highly cohesive and loosely coupled. So coupling in the sense dependency. So dependency, I am just browsing through that. Yes. Coupling and cohesion. Yes, you can see here. Uh, Given two lines of code, A and B. So some piece of code, they named it as A and B. They are coupled. So when do we say these piece of codes are coupled? So when B must change behavior only because A is changed. So the thing is, you can see here. So these two pieces of codes are said to be coupled when, so B must change behavior only because A has changed. The thing is,
Okay.
the piece of code present in A has changed some behavior. Then B also must change that behavior.
Mm.
Likewise, they are cohesive when a change to A allows B to change so that both add a new value. The thing is, whenever you make changes to A, then it allows to add changes to B also. It does not restrict. Do
Yeah.
you understand? So this
Yes.
point is known as cohesive. So there
Mm.
should be loose coupling in the sense dependency should be low.
Yes.
And there should be higher cohesion, high cohesion. So that
Mm.
is whenever you make changes to A, then it should allow to make changes to B also. So that
Yes.
new values will be added to those piece of code. Okay.
Okay.
You just browse through some more examples for this coupling and cohesion on Google. Okay.
Okay.
Yes, they may ask you. There is a chance. What is the difference between cohesion and coupling? So let me back. Yes. Then behavioral patterns. Behavioral patterns are concerned on how interactions happen between the objects. So you can see here behavior between the objects are present in the application. So some of these patterns are used for building loosely coupled systems. Okay. The purpose of
Okay.
behavioral patterns is to develop loosely coupled applications.
Okay.
Then creational pattern. So under creational pattern, you can see these are the examples. So abstract factory, builder design pattern, factory method, singleton, prototype. Okay.
Okay.
Among them, singleton and factory method are important. So
Oh,
they may ask you in interviews, what is singleton design pattern, and they will ask you to write the code for singleton design pattern also. Have you heard of this
okay.
singleton design pattern anytime?
No, personally, no.
Uh, this is applied in application development to obtain the database connection, so that
Yeah, okay.
your application will make sure that you are obtaining a single connection by using that URL, driver name, username, password. Okay.
Oh, okay.
Then structural patterns. So adapter, facade, and proxy, decorator, composite, bridge. So here maybe facade design pattern I have seen someone asking. Okay.
Okay.
Then behavioral patterns, chain of responsibility, iterator, observer, template method, command, strategy. These are the examples under behavioral patterns. Then
Mhm.
J2E patterns, MVC, business delegate, session facade, data access object, DAO. We have seen these things, right? MVC, DAO,
Yeah.
transfer object, service locator, intercepting filters.
Yeah.
So filters with servlets over there, which will intercept the request or responses. That is also a kind of design pattern. Okay.
Okay.
So you should be able to give an example under these categories, at least one or two
Okay.
examples. Okay.
Mhm.
Then so creational patterns. So here singleton design pattern, which is very very important. Many
Mhm.
times I have seen in the interview. So
Okay.
one instance of a class in the memory or one value accessible globally in the application. That's what.
Mhm.
For your class, there will be only one object always. Your application will make sure that whenever you are creating an object for a particular class, the object will be only one. Okay.
Okay.
And this will ensure that only one instance of a class is created and provide a global point of access to that object. I mean to say, any piece of code in your application can access this object. Okay.
Okay.
Then example, the task manager, run window, print spooler window in Windows operating system are examples that are developed using this singleton pattern. So task
Mhm.
manager, what do you mean by task manager? Have you seen task manager on Windows operating system?
Yes.
What is that?
It helps to see the network performance.
Right. This helps to see the network performance as well as the applications that are currently executing on our system. Right? I'll show you that.
Right.
If you give a right click on your taskbar, see Start Task Manager. So
Yeah.
this is Task Manager. So this one. Got it?
Yeah.
So
Get
this
it.
can be developed using that singleton design pattern. Okay.
Right. Okay.
Uh, Run window. So what do you mean with this run window?
Um,
I'll show you that.
okay.
On start, if you give this run window, got it?
Oh,
Command run will
yeah.
open, right?
Okay.
So this is also an example using singleton
Mm.
design pattern. And print spooler.
Mm.
What do you mean by print spooler?
Um,
No idea.
no.
Then I will give you an example. You can see here, I'm just printing this document. Okay.
Okay.
Print. I just printed. Okay. I don't have a printer connected to my machine
Mm-hmm.
actually. And you can see here a printer icon now. You can see here right side.
Okay.
I'm just clicking on it, and you can see here display print queue and here. So this is the print spooler. I mean, it will
Mm.
display the jobs that are currently running.
Okay.
So this window. So this
Mm-hmm.
print spooler can be developed using the Singleton design pattern. Okay. That is always one object is available for those things. Task manager also.
Mm.
Whoever opens the task manager, that is only one task manager is created. If you
Okay.
newly open the task manager, the same object is obtained. Got it?
Got it.
That is what it means. Singleton means.
Mm.
So run window also. So n number of times you open, it won't open n objects. It will
Mm.
open only one object. Got it?
Okay. Got it.
So you may be printing 100 documents, but the print spooler will be only one.
Okay.
Then caching, application context in application servers and loggers are designed using singleton design pattern. Okay.
Mm.
So
Okay.
caching, which we have seen with Hibernate, single level, first level, second level. Okay.
Yes.
Then application context is nothing but a component which helps in sharing. So the data which you put onto that component can be shared across your other
Application.
components present in an application, right?
Mm. Yes.
And logger, of course, we have seen logger also, right?
Yes.
Log4j.
The project. Yeah.
Logger is also designed using the singleton design pattern.
Okay.
Okay,
Okay.
you should be able to remember these examples for the singleton pattern also. All right,
Mm. All right.
then back. Yes, three easy steps to create a singleton. So assume a banking application. There is a process which verifies the account number and account holder name existence.
Mm-hmm.
So every time the user is clicking on a link, so the application is making sure that there is an account holder number and account holder name existing. Okay. To
Yes.
speed up the process, the account number and the name is placed in the memory as singleton, and the implementation goes like this. So the singleton implementation we are seeing now. Observe
Okay.
here. So here there is a class of bank account details cache,
Mm-hmm.
and here bank account details cache is a variable is created instance. Okay.
Okay.
Then there is a map with a number and name.
Yes.
Then there is a constructor.
Mm-hmm.
So constructor made private to prevent object creation.
Mm-hmm.
Yes, do remember in singleton design, I mean to say, in writing the code to obtain a single object always from the class, the rule is you need to mark your constructor as private
Okay.
to prevent object creation. Okay,
Okay.
then this is one rule. Please make a note this rule. And they may
Mm-hmm.
ask you how do you write code for a singleton design pattern. Then you can answer like I'll mark my constructor as a private.
Okay.
They may ask you why do you mark a constructor as private? What is the purpose? You can say to prevent the object creation. Okay.
Okay.
Then step 3. So synchronized method get instance added. So this checks for null and creates the instance. So here uh, you need to remember this piece of code.
Mm-hmm.
Here they are talking about creating an object for our own class bank account details cache class. Okay.
Okay.
You can see in the class bank account details cache, a method is added. What method? Get instance method, which will give
Mm.
the current class object to us. Okay. Get instance.
Okay. Yes.
These are this is a user defined class and user defined methods they are. Okay.
Okay.
And you can see in get instance method the piece of code. So here if instance equals to null, you can see over there while creating the instance here, I did not initialize it in the class variable. Can you observe
Mm.
over there bank account details cache instance I have not initialized. It means it is null, right?
Right.
Now if instance equals to null, then instance equals to new bank account details cache. Here we are calling the constructor and creating an object and assigning to that instance remote control, instance reference variable. Got it?
Got it.
We are making sure that there is no object with mapping to that instance reference variable with this if condition. Got it?
Oh, got it.
So when it is null, then create an object for it.
Mm-hmm.
Then you map an object for this reference variable. Got it?
Got it.
Then you are initializing. So instance dot account details. There is a map, right? So you are initializing your map. And onto that map, you can put some data also. So what
Yes.
data? Load account details. There is another method which would add data. You can see load account details here.
Mm-hmm.
Account details, some name and number. Name and number are added. Okay.
Okay.
And finally, return that instance. Got it? So whenever an object is created, the object would be ready with those account details in the map. Got it?
Got it.
And here you can see we are making use of that. So here validate. So there is a method validate which takes the account number and the name.
Name.
And from account details, so account details. So this account details, where do we have reference? Map. Okay, map.
Mm-hmm.
So get. So you are passing the account number and you get the value.
Mm-hmm.
And the value, if it is not equals to null and value dot equals to account name, you are obtaining the boolean value. Okay. That means if there is a name associated with that account number, it returns true, else false.
Okay. Okay.
So here, two things are you need to remember. You write a class. For that class, we are creating always a singleton object. I mean to say, whenever you are going to create an object, the object would be single. There will not be multiple objects.
Okay.
So one thing, you mark your constructor as private, and second thing is you write a method which would return the instance of your class like this. Check whether it is null, and then you create an object. Finally, return
Okay.
that object. Okay.
Okay.
And this singleton singleton pattern with an example is explained on the screen. Creating a bank account details. Okay.
Okay.
Please do remember these two pieces of code. Step 2, step 3. Okay.
Okay.
Then factory pattern. So factory design pattern creates objects without exposing the instantiation logic to the client. So this is what happens.
Mm-hmm.
Creating an object would be associated with some piece of instructions, right? Java piece of instructions.
Mm-hmm.
So that piece of instructions are hidden from the client. Okay.
Okay.
And you can see here there is a factory here which is delivering objects. The client is asking, I need a car object. So the factory is going to deliver a car object. Likewise, I need a train. The factory is going to deliver a train. So I need a bus. So the factory is going to deliver a bus object. So whatever the client is asking, those type of object is delivered by this factory. Got it?
Got it.
And the factory pattern is used to dynamically create objects at runtime based upon client input. That's what client is giving. Hey factory, I need a car object. Then factory intelligently chooses the car object and gives.
Yes.
So it happens at execution time. Benefits. So loosely couples two layers by which changes in one layer do not affect other layer. This is the reason why we go for factory pattern. Loosely coupled. Okay.
Okay.
Changes in one layer will not demand or will not affect the other layer. Okay. Then, so example, DAO implementations use factory patterns. For example, if there are two DAO, one for employee table and the other for customer table. So the factory can be used for returning appropriate DAOs to the client for processing. That's what. If client is asking for employee, then employee DAO will come into picture. If the client
Yes.
is asking for customer, then customer DAO. Got it?
Mm. Got it.
Right. And here you can see some piece of code that talks about factory pattern. Okay. So here, observe that there is an interface here.
Yes.
Interfaces generally we begin with a capital I. Okay. In project development, you should write interfaces like this. It should begin with I and the name, of course. Interface
Yes.
name. Okay.
Yeah.
Vehicle.
Okay.
So vehicle
Yes.
interface is having two methods, drive and stop. Now my car is implementing this I vehicle. Okay.
Yes. Okay.
So here the step one, we created an interface for the family of objects you are going to create using factory. Then two, create the object implementing the interfaces created. So here you need to write your class and it should implement the interface. And in your class you are going to provide the code
Yes.
for driving and stopping.
Mm-hmm.
Then you can see there is a vehicle factory. So
Mm-hmm.
step three. So create the factory based on upon the inputs that are provided, and you can see. So here, vehicle factory, there is a method create vehicle. Create vehicle is returning an interface vehicle reference. Okay.
Okay.
To this create vehicle, you are passing a string. Hey, I need car or a bus or a train. So dynamically I can give the input. Okay. That input is nothing but vehicle type. Okay.
Okay.
So for this I vehicle, a reference variable is created and it is given null. Later on we populate with the appropriate object. Okay.
Okay.
I vehicle type is car, then this vehicle equals to new car. If I
Mm-hmm.
vehicle type is bus, then new bus. Vehicle type is train, then new train. Got it?
Okay.
Finally return the vehicle. So this method is acting as a factory of objects and it is returning the object based upon the input provided by the client. Got it?
Yes.
So this is
Got
a
it.
pattern. One of the important patterns like Singleton, they may ask you to write piece of code for factory pattern also.
Okay.
Nothing. You are going to
Yes.
create an interface and an implementation for that. And you are going to create, I mean, there may be bus implementation also. Maybe train implementation also, right? Those two are other classes which are
Right.
implementing our vehicle interface. And you are going to create the objects of those car, bus or train in a method here. Okay.
Okay.
So whenever you say, I mean, whenever you invoke create vehicle method and pass this vehicle type, inside this code runs creating the object. So we are just passing the vehicle type to this method. That's it.
Yes.
Then configurable factory pattern. Okay.
Mm-hmm.
Okay.
So here the thing is we have add a new register method. Here you can see the thing is let me show you the code again. Vehicle, I vehicle,
Mm-hmm.
drive, stop are two methods, and create vehicle is a method present in the I vehicle. Okay.
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 And to this vehicle, we have implementation. So car implementing I vehicle. And here you can see vehicle factory flexible. So here there is another class vehicle factory flexible. So what it is doing is it is going to register the objects. So here you can see vehicle factory flexible class has a method register vehicle. Okay.
Yes.
This register vehicle is taking the vehicle type and the vehicle reference. Okay. And it is
Okay.
going to use that vehicle registry, which is a map kind of thing. You can see a vehicle registry is a map. map,
Yeah.
hash map.
Yes.
So onto that map, you are going to put the vehicle type and the vehicle. Okay.
Okay.
So whenever you are invoking this register vehicle method, the map would be populated with a so and so vehicle. Okay.
Yes.
Yeah.
And here you can see in the static block. So to this vehicle factory flexible dot register vehicle, the car object is passed. So car vehicle type car and car object. Okay.
Yes.
Okay.
Then create vehicle. So create vehicle is a method here which takes the string type, that is vehicle type, and you can
Yeah.
see here from vehicle registry, because vehicle registry is a map which contains all those objects, car, bus, train, right.
Right.
From
Right.
that you take the vehicle type. So get vehicle type and give the object for that. Got it?
Okay. Yeah, got it.
So finally return vehicle. So vehicle, this vehicle reference dot create vehicle. So there is a create vehicle. I mean the same method we are calling. Okay.
All right.
Okay.
And question, right?
Yeah.
So here create vehicle. Here we have a create vehicle here. You can see a create vehicle. So which is returning here. We are making use of car, a new car, and it is returning a car object finally. Okay.
Okay.
So step 2, in the object create a static block to register the object with the factory. So we need a static block for the purpose to register the vehicle objects. Then step 3, create a method to instantiate this object, to create the object. And step 4, factory to pick the object from registry and invoke the objects with the help of create method. Okay. So all these are 4 steps involved in configuring your factory pattern. That is, you can add n number of objects to your factory. That is, you are registering n number of vehicles with this piece of code. Okay.
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 This is not much important, but I'm just highlighting. Okay. The first two are very important: factory as well as singleton.
All
Okay.
right.
So abstract factory pattern. So abstract factory pattern is a super factory, a factory that creates other concrete factories. So I
Mm.
have seen a question somewhere. What is the difference between abstract factory and factory design pattern? So here you can see these are the actual objects: car objects, train objects, bus objects.
Mm-hmm.
So there is a separate car factory which produces car objects,
Oh,
train factory which
okay.
produces train objects, bus factory which
Mm.
produces bus objects. Got it? These are
Yeah.
concrete implementations of the factories. Okay, and we
Yeah.
have an abstract
Okay.
factory here.
Mm.
So this provides a way to encapsulate a group of individual factories that have a common theme or creating families of similar objects. Okay.
Okay.
So when a
Okay.
client is asking for a car, then the abstract factory will communicate with this car factory and obtain the object. Right?
Right.
Okay.
Yes. So factory patterns are used to dynamically create objects at runtime based upon the standard inputs or configurations. We have already seen the usage.
Yeah.
Benefits: loosely coupling of two layers by which changes in one layer do not affect the other layer. Okay.
Okay.
Mm.
It means tomorrow I can add a ship factory here.
Mm-hmm.
I just put a method here in the abstract factory then. Its implementation would be here. Right?
Yes.
Okay.
Okay. So builder pattern, not much important, just for our knowledge. Okay.
All
So
right.
builder is a
Okay.
pattern used for building complex fine-grained objects and parse a complex representation and created object. Uh, XML. What do you mean by XML?
Extended marked
Okay,
language.
right. What is the purpose? We have HTML, right?
Yeah.
Then why is it? Why is this XML? Difference between HTML and XML? Any idea?
Maybe by the definition, the HTML is hypertext markup language, and the
Yes.
other one is extended.
It is extensible markup language, XML.
Yeah.
The basic difference between XML and HTML is HTML is for viewing purpose. The design part on the front end. Got it?
Got it.
XML is for data transfer.
Oh,
If you
okay.
want to transfer the data from one layer to another layer, you will be using XML.
Oh, got it.
Right. So you can see over there XML. There is an XML document which talks about employee data. Okay. Employee
Yes.
open tag, somewhere down there will be employee close tag.
Yeah.
Then employee's name, ID, and some set of tags, account information, account number, balance. Okay.
Okay.
So parsing a complex representation and creating an object. So there may be XML parsers which would read this XML document and create employee object and account object. Got it?
Got it.
So the builder pattern is used in that scenarios. Okay.
Okay.
So the logic of building complex fine-grained object is centralized and reused across the application rather than replicating it. Okay.
Yeah.
So builder versus factory pattern. Factories are usually a single line of code to instantiate the object and return it. Builders are usually a utility which has complex logic for building the objects because it has to read the XML document and then create the object, right?
Right.
Definitely it involves a complex logic over there.
Yeah.
They have to parse that XML file. Whereas creating an object is very simple compared to that parsing, right?
Yes.
So in real world, the builder patterns are used in tandem with factory patterns. Okay. So let us take the vehicle factory example. The car factory can be using a car builder, and bus factory would be using a bus builder. You can see here.
Yeah.
So car factory further using car builder and then creating car objects. Okay.
Yeah.
Right. Structural patterns. So structural patterns, the bridge pattern is applied. Uh, there is a need to avoid permanent binding between an abstraction and the implementation. Then you go for bridge. And the implementation and the abstraction need to vary independently. Let us see by example. So here you can see. So here there is a power button. So here power button, and you can see here these power buttons are operating the fan. The power button interface, if you see, it may be this kind or the other kind. But still, whenever you use them, the fan gets rotated, right?
Yeah.
So any change in the interface will not result in the change in the implementation. These switches are the
Yeah.
interface for us, and fan is the implementation.
Yeah.
So this switch shape may be changed, but it will not be having implementation. It will not be having effect on the implementation, right?
Yeah.
That's what. So the bridge pattern. So bridge pattern, some piece of code you can see. We are highlighting here bad design, bad practice, and good practice, both the things. Okay.
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 There is an interface switch. It has switch on, switch off methods to switch on and to switch off the fan. Okay.
Yeah.
Okay.
Fan implementing switch, and you provide implementation switch on, fan switch on, fan switch on. Okay.
Yeah.
Right.
Now, if a new method is added in the switch interface, the fan implementation needs a change here, right?
Yeah.
Because the class will demand implementing the new method that is added in the interface.
Yeah.
Because car is,
Yeah.
I mean, the class is implementing the interface, right?
Definitely. Yeah.
Right.
Yes. Yes. The good practice. Observe here. There is a switch interface. Switch on, switch off. Now, a new method is added. Change. Okay.
Okay.
If you observe here, there is a good fan that is extending an abstract switch. There is an abstract class in between that.
Yeah.
We don't
Okay.
have a direct implementation here. We provide implementation through abstraction. Okay.
Yeah.
Observe here, my good fan extends a abstract switch. So what is abstract switch? This abstract switch is implementing the above switch interface.
Yeah.
And if it is abstract, then in the class there may be concrete methods as well as
Yes.
abstract
Abstract
methods.
methods.
So switch on, switch off are abstract methods.
Yeah.
And change, you can see here for this change method, they have provided
Is
code
the
here.
public. The concrete.
Yeah.
We have provided the code here, right?
Yeah.
And here you can see. So in your, I mean to say in your switch interface, if you add a new method now, will your good fan class have an impact? I mean to say, will it demand to override that new method? No necessary, right?
No.
Because
No.
there is an abstract switch here,
Yes.
right?
Definitely. You're right.
So step 2. So implementer should extend the abstract class factory rather than the interface directly. That's why.
Okay.
Okay.
Makes sense.
So new method change added without impacting the implementer fan, good fan, right?
Yes.
Yeah.
Right.
That's what bridge pattern is. This is a good design practice. Okay.
Okay.
Proxy patterns. One of the important things, proxy pattern. We will see this proxy pattern implementation in Hibernate with an example.
Okay.
We have 2 more samples to work out on Hibernate. With that, we can put a full stop on Hibernate.
Okay.
One is CRUD operations, that is create, retrieve, update, deleting an object,
Okay. Yeah.
model class.
Great.
Second
Okay.
one is Hibernate implementation uses this proxy. Okay, I'll show you how it uses this proxy, and it is very helpful in Hibernate.
Alright.
We don't need to, I mean, configure all these in Hibernate. Hibernate by default provides this proxy kind of thing. Okay.
Okay.
Then, so what is proxy? Proxy pattern is used when you need to represent a complex with a simpler one. Look there, a complex one is represented with a simpler one over there. The simple object is called the proxy for the complex object. Got it?
Got it.
And here you can see, so there is a passport office in Delhi, India's capital city. And we
Okay.
have 2 other branches in India, Chennai and Bangalore.
Yeah.
These are locations in India. So here a resident is applying for a passport via this
Office.
office, this
Okay.
passport. And here this proxy pattern, if creating an object is too expensive in time or memory, then we go for creating the proxy objects
Okay.
and load a remote object over the network even at peak periods also. Okay.
Okay.
Okay. Okay.
Then software example, So cache is a good example for proxy pattern, caching. Okay.
Okay.
So to reduce the response time taken and unnecessary database calls, cache is the proxy for database.
Okay.
Just look here. Yes. There is a interface service. Okay.
Yeah.
Yes.
Calculate tax, calculate returns are two methods in it. So these are the
Yeah.
services provided. Okay.
Yeah.
Yes.
This implementation, there is a class which is implementing this service. Okay. And you are providing the implementation for calculate tax and calculate returns. Okay.
Yes.
Yes.
Here, actual service with the method implementation here in the class.
Mm-hmm.
Okay.
Yeah.
Yes.
And you can see here proxy service. So proxy service created and wrapper inside to the service method. In the proxy, the method can invoke the original proxy, original service, and let me explain. So here the thing is, there is a proxy service implementation that is implementing the interface. Okay.
Yeah.
Okay.
We have a service implementation class that is implementing the iService.
Mm-hmm.
Likewise, we have proxy service implementation that is implementing this iService.
So
Okay.
yes.
We have definition for calculate tax and calculate returns in this proxy.
Mm-hmm.
So what this proxy is doing, look there, new service implementation. I mean, for this class, it is creating an object, right? New service
Yeah.
implementation.
Yes.
It is calling the calculate tax method in this class, service implementation class.
Okay.
And if you see, the calculate tax is blank here.
Yeah.
And here we are invoking that method here in the proxy,
Yes.
right? And calculate returns, you can see new service implementation object dot calculate returns. Got it?
Got it.
So here for the client, observe there, in my client program, I am performing a tax computation.
Mm-hmm.
What I'll do is new proxy service implementation. I am using the proxy here. So client invokes the proxy service. Okay.
Yeah.
Mm-hmm.
What proxy is doing internally? It is going to calculate tax. You can see calculate tax. What calculate tax is doing? It is going to further create the object for the actual class service implementation
Yeah.
and invoke the calculate tax. Okay.
Yeah.
Yes.
It means that the client is given a proxy object instead of the actual object.
Oh, yeah.
Okay.
And here you can see invoke the original service or provide a dummy service implementation inside this proxy service implementation. This one, calculate tax.
Okay.
Fine. So behavioral patterns. For now, I cannot go with behavioral patterns, and I'll be late. It's 6 here. I'll continue these behavioral patterns in my next session. Okay.
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 Fine then. I'll see you tomorrow, same time, 5
Okay.
a.m.
All
Okay.
right. Thank you.
Yes. All right.
Yeah.
All right. Excuse me, sir.
Yes.
Did you already work with that example we gave you? Because until now
Yes.
we can get the
Yes. Yes. The thing
okay.
is, there was a configuration problem. Nothing problem with the code actually. The jars you need to put. So make sure these jars are available. Just a minute. I'm opening an image to show you the jars that are to be
Okay.
available. Yes, look here. Make sure in your lib these jars are available. I'll share this screenshot with you, okay?
Okay.
And try executing, okay?
All right.
There is nothing problem with the code. Sure, because that's the configuration problem. I told you, right? There is a problem with
Yeah.
configuration. So try with these jars. Check whether these jars are available in our library or not. If not, you just download and that, okay?
Yeah.
Yeah.
Because this works with this jars, so okay?
Are these the same as
Oh,
the one you sent to Mike?
No, I did not send anything.
You sent him a screenshot of the lib folder.
No,
You
I did not. No.
Okay.
I forgot to tell you about this because I done it maybe 2-3 days ago. I forgot to share with you.
I
Anyhow, you
mean,
reminded me.
we received some email from Mike. He said that it was coming from you, and you were talking about this lib file, and they were an attachment of a
No,
screenshot of a lib folder. So I will just wanted to know if this is the same as the
no,
one. Okay.
no. I just gave a suggestion. I gave a suggestion. What the thing is, with our Java project and Hibernate samples, we have been putting the jar files in source, right?
Yeah.
With
yes.
web applications, the jar file should be in the lib folder in web content. That's what I
Yeah.
highlighted. Okay.
All right. No
Yes.
worries. Just
All right.
wanted to make sure.
Okay.
Okay. Fine.
Okay.
And please make a try and let me know in the other class. Okay.
Sure. Yes.
Okay.
I'll send you this image. Okay.
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 All right then. I'm closing the session and see you tomorrow at 5 a.m. IST. My time.
All right. Yes.
Okay.
Okay.
Bye.
Bye.
Bye.